In the outer regions of our solar system, beyond most of the planets, lies a vast, cold, donut-shaped area known as the Kuiper Belt. It stretches past Neptune, the eighth planet from the Sun, and contains thousands of icy bodies and remnants from the early solar system. The first object discovered in the Kuiper Belt was Pluto, which was found in 1930 by astronomer Clyde Tombaugh. At that time, astronomers were unaware of the full extent of the outer solar system and believed Pluto to be a solitary planet, despite its irregular and tilted orbit. It wasn't until 1992, over 60 years after Pluto's discovery, that scientists found another Kuiper Belt object, KBO, confirming that Pluto was just one of many icy worlds in this distant region. The discovery of additional KBOs proved that the Kuiper Belt was a vast zone filled with small, icy bodies, remnants of the early solar system. This shifted Pluto's classification from a planet to a dwarf planet in 2006, following a change in the definition of a planet by the International Astronomical Union. The Kuiper Belt was named after Gerard Kuiper, a scientist whose 1951 paper theorized the existence of objects beyond Pluto. Although Kuiper did not discover the belt himself or provide detailed predictions, his work laid the foundation for later exploration. Eventually, the region and its discoveries became associated with his name. The Kuiper Belt begins just past Neptune's orbit and continues outward. Interestingly, Neptune's gravitational influence determines the inner boundary of the belt rather than Pluto's. This region is believed to contain materials left over from the early solar system, preserving conditions from around 4.6 billion years ago. These ancient remnants include well-known dwarf planets like Haumea, Makemake, and Eris, along with Pluto and its moons. Haumea, discovered in 2004 by a team led by Mike Brown, has an elongated shape likely caused by its rapid rotation. It's approximately 1,960 kilometers wide. Makemake, found in 2005 by the same team, is about 1,430 kilometers wide. It has a bright surface composed of methane, ethane, and tholins, but lacks a significant atmosphere. Eris, also discovered in 2005, has a diameter of 2,326 kilometers, making it slightly smaller but more massive than Pluto. Its discovery played a critical role in prompting the reclassification of Pluto. The Kuiper Belt is much larger and more massive than the main asteroid belt located between Mars and Jupiter. It may contain 20 to 100 times more mass than the asteroid belt, even though much of the original material has been lost. According to the NICE model, the giant planets, Jupiter, Saturn, Uranus, and Neptune, migrated over time, disrupting the belt's structure. As these planets shifted, their gravitational forces flung many icy objects out of the solar system or scattered them inward. What remains are fragments, literally shards, of a once much larger collection of material. Over time, collisions between objects in the Kuiper Belt have broken many of them into smaller pieces. Some of these fragments become comets, while others are pulverized further. The solar wind carries away the resulting dust, contributing to the gradual erosion of the belt. Scientists estimate that the current mass of the Kuiper Belt is less than 10% of Earth's mass. Interestingly, many Kuiper Belt objects have moons, with some forming binary systems. In these systems, two similar-sized objects orbit a common center of mass, known as the barycenter. Some are contact binaries, where the two bodies are physically touching, forming shapes that resemble a peanut. These configurations occur due to mutual gravitational attraction. The Kuiper Belt was first entered by a spacecraft in 1983, when NASA's Pioneer 10, launched in 1972, passed through. Although Pioneer 10 didn't explore any icy worlds, since only Pluto had been discovered by then, it was a groundbreaking mission. Later missions, such as Voyager 2 and Cassini, provided more insight into the outer solar system. For instance, Voyager 2's flyby of Neptune's moon Triton in 1989 and Cassini's study of Phoebe in 2004 offered evidence that some moons may have originated in the Kuiper Belt. A major breakthrough came in 2015 when NASA's New Horizons probe flew by Pluto, capturing high-resolution images and collecting invaluable data. While en route, it also photographed a Kuiper Belt object known as 1994 JR1 from 170 million miles away. Around the same time, the Hubble Space Telescope helped identify new potential targets for New Horizons. It discovered faint objects billions of miles from Earth, including 2000 FV53, first spotted in 2000, and others in 2014 like 11-1-so-M1, 1103-wa, and 07209F. These discoveries further expanded our knowledge of the Kuiper Belt. Another leap in our understanding came with the launch of the James Webb Space Telescope, JWST. This advanced observatory uses infrared light to detect heat signatures from cold, distant objects. Since the Kuiper Belt is extremely cold, it emits long, wavelength infrared radiation. JWST's sensitive instruments are ideal for studying these emissions, allowing scientists to determine an object's chemical composition, including the presence of water ice, methane, and ammonia, each with unique infrared fingerprints. JWST's 21-foot-wide mirror allows it to gather faint light from distant sources, making it especially effective at observing dim, faraway Kuiper Belt objects. The telescope's sunshield blocks heat and light from the sun, keeping its instruments cold and stable for infrared observations. These tools provide sharp, detailed images and allow precise measurements of surface temperatures and features. Among JWST's key instruments is NIRCam, which captures high-resolution images in the near-infrared range. Another tool, NIR-SPEC, breaks incoming light into its individual wavelengths for spectroscopy, revealing an object's composition and temperature. The MIRI instrument operates in the mid-infrared range and works alongside NIRCam and NIR-SPEC to provide a full picture of Kuiper Belt objects. The Fine Guidance Sensor, FGS, ensures accurate pointing, while the Near-Infrared Imager and Slitless Spectrograph, NIRIS, helps maintain clarity and measurement precision. One particularly notable Kuiper Belt object is Arakoth, named after the Powhatan, Algonquian word for sky. It's about 22 miles long and 12 miles wide, with two connected lobes measuring approximately 13 and 9 miles. This makes Arakoth a contact binary, an object formed from two bodies that gently merged. Despite its irregular shape, Arakoth's orbit is stable and predictable, with a period of 298 years. While the Kuiper Belt is often confused with the Oort cloud, the two are very different. The Kuiper Belt is a disc-shaped region located beyond Neptune, and it's the likely origin of short-period comets, those with orbits of less than 200 years. In contrast, the Oort cloud is a spherical shell surrounding the solar system, extending from roughly 2,000 to 200,000 astronomical units from the Sun. It contains icy bodies that are believed to be the source of long-period comets, which have highly elliptical orbits. Both regions are essential to our understanding of the solar system's history. The Kuiper Belt, though eroded over time, still holds many secrets. Continued exploration using tools like the James Webb Space Telescope will help uncover more about the formation, evolution, and structure of this distant frontier.